In this very lesson, we shall be looking at the types of sets. Remember, we are still on sets, and under the types of sets, we shall be looking at the following types of sets. We shall be looking at the empty set, which is also known as the null set. We shall be looking at the unit set or the singleton set. We shall be looking at the finite, the infinite, the equal, and then equivalent set. So these are the types of sets that we'll be looking at in this very lesson. So let's take them one after the other, and then we elaborate on them with what examples. So the first one that we are starting with is what? The empty set. So when we talk about the empty or the null set, it is a set which contains no elements. So when you have a set which contains no element, then you can classify that set as what? An empty set. A null or an empty set is mostly denoted with this very symbol. So it is denoted with this symbol, this, or what? That. So anytime we come across this symbol or this very symbol, it should tell you that we are talking about what? The null or empty set. Now, this set, so let's take it that you have a set A which contains this element. Okay, now this set is not an empty or a null set, because this seems like putting an empty box inside another empty box. So it means that with this set, it contains one element. So this set is not an empty set. For an empty set, it is either this or that, but not what? Both. The moment you place this inside this bracket, it ceases to become what? An empty or a null set, but rather another type of set. Is that clear? Good. Now let's look at examples of an empty set. Under the examples of an empty set, we can talk of, let's say you have a set A, and then this set A contains no element. So this is an example of an empty set. We can also look at this type of set. So we can look at a triangle with 6 sides. So it means that if we have to list the elements for this particular set, we are going to get what? An empty set, because we don't have any triangle with 6 sides. So after listing the elements for this particular set, we are going to get no element, and therefore this set becomes what? An empty set. We can also look at, if you have set C, and then this set C contains, so we have set C which contains the element human beings with what? 8 heads. We all know that we don't have any human being with what? 8 heads. So if we have to list the element for this particular set, we are going to get what? An empty set. So this set is what? A null or an empty set. We can also talk of, all months of the year beginning with K. So if we are to list the element for this particular set D, you realize that we are going to get what? An empty set, because we don't have any months of the year that begins with the letter K. So if we are to list that element for that particular set, we are going to get no element for that particular set. Let's look at the last one. So we have even numbers between 16 and then 18. So if you have to list the element for this particular set E, you realize that we are not going to get any even number that is between what 16 and then 18. So this set also becomes what an empty set. So these are examples of an empty set, and I believe you can give more examples on that. Let's look at the next one, which is called the unit set or the singleton set. Now we are looking at the unit set or singleton set. Now when we talk about the unit set or a singleton set, it is a set which contains only one element. So when you have a set which contains one element, then that set is what? A unit set or a singleton set. So examples of a unit set or a singlet set is, let's say we have example. So you can talk of, let's say you have a set A which contains the element, let's say red. So this is a unit set or a singleton set because it contains only one element, which is what? Red. You can also look at, let's say you have set B. So you also have odd factors of 16. Odd factors of 16. This set is what? A unit set. Okay, because if you are to list the factors of 16, we are going to get only one element, which is what? An odd factor. So if you care to know, let's list the element and then see. So we have 16. Under the factors of 16, we have what? 1, 2, 4, 8, and then what? 16. So these are the factors of 16. And then we are looking at what? Odd. So which of these numbers is an odd number? You realize that we are going to get only one to be what? An odd number. So we are going to get this set. And this set is what? A unit set because it contains only one element. Therefore, this set is what? A singleton or a unit set. So this means that sometimes you have to list the elements for that particular set before you can come out with a type of set. So when we are able to list those elements for the set and then realize that it's only one element in the set, then you can say that that set is what? A unit set. So an example we can also talk of. So we also have another set. X is such that x is greater than 3 and this x is less than 5, where x is an integer. Good. So you know that integers are positive and negative whole number. So if you are to list the element for set C, you realize that we are going to have only 4. And this set becomes what? A unit or a singleton set because it contains only one element, which is 4. Good. Let's take another one. So we have the last example. All months of the year beginning with the letter F. All months of the year beginning with the letter F. So if you have to list the elements for this particular set, you realize that we are going to have only February. And this set becomes what? A unit set or a singleton set because it contains only one element, which is what? February. Let's look at the next type of set, which is what? The finite set. So when we talk about a finite set, then we are looking at a set whose last member can be found, or a set which comes to an end. So when you have a set that the last element can be found, or you can locate the last element, then you can classify that set as what? A finite set. So an example of a finite set, we can talk of, let's say you have set A, which contains the elements 1, 2, 3, and then 4. Now this is a finite set because the last member or element can be found, and the last element is what? 4. So this set becomes a finite set. Good. Another example of a finite set is, let's say you have set B. This set B is also a finite set because we can list all the months of the year, and we know that all the months of the year, it comes to an end at where? December. So this set also becomes a finite set because we know the last element or the last member. So this set is also a finite set. Now we can also talk of, so we have set C, which contains the elements or letters of the English alphabet. We know that letters of the English alphabet ends, it comes to an end, and we can locate the last letter of the English alphabet. So this set becomes what? A finite set because the last element can be found, and that is what? Z. So this set is a finite set. Let's take the last example. So the last example of a finite set, we are looking at this particular set. X is said that X is greater than 1 and X is what? Less than 10, where X is an even number. So if you are to list the elements for this particular set, we are going to get 2, 4, 6, and then 8. So this set becomes what? A finite set because the last member can be found, and that is what? 8. Let's look at infinite sets. So when we talk about the infinite set, we are referring to a set whose last element cannot be found, or a set which does not come to an end. So an example of such sets are, so we have examples. We can talk of, let's say you have set A, and this set A contains what? Natural numbers. So you realize that if you are to list the element for set A, which contains natural numbers, we are going to list these numbers till the kingdom come, because we don't know the last number for the natural number. So this is an example of an infinite set because the last element cannot be found. Another example is, let's say you have set B, which contains, let's say, multiples of 4. So you realize that if you have to list the element for set B, we are going to list all these elements till the kingdom what? Come. Because we don't know the last element for the multiples of. Let's move on to the equal and then equivalent set. Equal and then equivalent set. So let's look at equal sets. Now, two or more sets are said to be equal if they contain the same element and then the same number of elements. If these two sets contain the same element, meaning that the elements within these two sets are identical, and then the number of elements within these two sets are the same, then we can say that these two sets are equal sets. An example is, let's take it that you have set A, which contains the elements 1, 2, 3, and then 4. And then we have another set B, which contains the elements 4, 2, 1, and then 3. Now realize that the elements in set A and set B are identical because we have 1, 1, 2, 2, 3, 3, 4, 4. So the elements in these two sets are identical. Now let's look at the number of elements for set A. So number of elements for set A. Now we are going to get 1, 2, 3, 4. So it means that set A contains 4 elements. Now number of elements for B, we have 1, 2, 3, 4. To realize that the number of elements in set A and set B are the same, and the elements within these two sets are identical, then we can say that these two sets are equal sets. Let's take another example. We have, let's say, set A, which contains we have set A, which contains even numbers, and then set B contains multiples of 2. So if we are to list even numbers, realize that we are going to have 2, 4, 6, 8, 10, 12, 14, 16, up to infinity, right? Now let's list the elements for set B. We are still going to get multiples of 2. We have 2, 4, 6, 8, 10, 12, 14, 16, up to infinity. So realize that the elements in set A and set B are the same. And then the number of elements in set B is also going to be the same, because we are talking about what? Even numbers. And we are talking about what? Multiples of 2. All of these numbers are running up to infinity. So definitely the number of elements for set A is surely going to be the same of number of elements for set B, because all these numbers are running to infinity. Good. So when we talk about the equal sets, then we are saying that two or more sets having the same element and then the same number of what? Elements. Then we can say that these two sets are equal sets. Let's look at the last one, which is called the equivalent set. Equivalent set. Equivalent sets. So with equivalent sets, if two or more sets are having the same number of elements, then we can say that these two sets are equivalent sets. So with this one, it's talking about the number of elements, but not the elements themselves. It is talking about what? The number of elements. So if you have, let's say, set A, let's take set X, which contains the element, let's say 1, 2, and then 3. And then set Y contains the elements A, B, and then C. Now the number of elements in set X, we have how many elements? We have 3. Now number of elements in set Y, how many elements? 1, 2, 3. So you realize that the number of elements in set X is the same as the number of elements in set Y. If that happens, then we can say that these two sets are equivalent sets. So with equivalent, we talk about what? The number of elements within these two or more sets. Another example under equivalent set, let's say that you have God. So what we are going to do is that we are going to find the number of elements in P. So the number of elements in P, we are going to have how many elements? 1, 2. So we have 2. Then we have number of elements in Q. We are having how many elements? We have 2 elements. So realize that the number of elements in set P is the same as the number of elements in set Q. So you can say that these two sets are equivalent sets. So this brings us to the end of today's lesson. I'm going to list some tutorial set questions on the board. Can you pause the video? You write them down. You try and answer them. So these are your tutorial sets. See you tomorrow. Bye bye.